Hello everyone, it's Alex here and welcome back to my channel. And today we're going to talk about the power of protocols in Swift, why we should use them and how to use them the best way possible. So first of all, let's jump right into the code and talk about why we should use protocols. The two most obvious reasons are to encapsulate our logic and abstract some layers one from another and make sure we'll be able to unit test our classes. For instance, if we have a class that has some dependency to, let's say, some data provider, that is a data provider, and we have this class here implemented like data provider and method, some method, doesn't matter what it is. We may just want to inject the dependency into our class foo, and in some method inside do some work. We can just simply call our data provider method and so on and so on. But here's like some custom implementation. But imagine this data provider actually uses some URL requests and maybe creates like URL session that is shared, and it creates like some task. Let's go the simplest way with some URL string. Or get something. In this case, actually it's something like this. With URL, data task, with URL and some compression handler with data, response, and error. So we perform some stuff here and do some logic here, and maybe it's our main view model for our app, and yeah, we do some stuff like this. In this case, we cannot actually test this view model because we have data providers, so whenever we create a unit test, it will depend on the access to the network. So this is one of the obvious reasons why we use protocols. So for instance, we can create a data provider protocol, or actually depends on the naming convention. Maybe you want to call it stuff like data providing, as some people suggest, and this will implement this. Or maybe if you want to explicitly show that it's a protocol, which is fine too, you can just conform this protocol. In this case, you'll have your method here. As we all know that when we instantiate a view model, we can create data provider, that will be data provider, and we'll just pass it here. But if we just use a protocol here instead of data provider, this thing still works because this is conformed to this protocol. And for instance, in some case you decide to create like some other thing, maybe instead of the web you are using maybe, I don't know, local data provider that just can conform to the same web protocol. In this case, you can have this method that will just ask like a file manager default and read I don't remember, contents or something else, like read some data from some file, like let data equals at path, I don't know, some directory. And in this case, you'll be just able to replace it with your local data provider, that is local data provider, and just put it here, and this still works. Or for instance, you have like core data manager that conforms to data manager protocol and you want to switch from core data to Realm or something else, and in this case you'll just replace it behind your scene and just use it, and nothing outside of this data manager implementation changed. View model doesn't care and shouldn't care about that. But what's one of the greatest things of protocols? Because you can do so much with protocols, and let me show you some stuff. For instance, if you want to have some method, I don't know, some other method, and you want to make it optional, you can always create an extension of data provider protocol and implement this method. And maybe it will be something other method. And in this case, for instance, in data protocol, you may still re-implement this method, and you can call it re-implemented method. And for instance, we just call this data provider other method, and we'll just maybe or not here, but we'll do other work. In this case, you use like this, and for instance, we will have two view models, 1 and 2, and just if we call do other work for both of them, yeah. So as you can see, we re-implemented this method for data provider. So let me even just hide this. So if we run it, we should get the words re-implemented written in the console. Yeah. So, but if you use another view model that has local data provider that doesn't have other methods re-implemented, the one that's written here, we still can use it here. So as you can see, main view model calls this other method and it says this one. So basically, this is a default implementation for our protocol. We can use extensions for protocols for this. And that's not it. Let's say we have another method that maybe called third method that has maybe number that will be int, string that will be string, and maybe optional string, like some flag that is boolean. For instance, in most cases our flag should be false, but we cannot just add this here because default arguments not permitted in the protocol methods. But what we can do is to create another function that will be quite similar to ours. So for instance, this one may be 0 by default, this may be nil, and this may be, for instance, false, or even, for instance, this one doesn't have a default value by some reason. And this just simply calls our the same third method, and that we'll just simply call this method. So here, in our data provider protocol, we just need to implement our third method here that will print something like, I don't know, maybe number, there is number, string, the string, or nothing, and maybe flag, maybe even separate these three strings. Yeah, so for now let's maybe create third method here, or maybe we don't even need this anymore. Yeah, let's just comment it out for now. And yeah, so for now we don't need any of this, but for instance, we just want to call this method data provider third method. So in our case, we would need to pass something like this to make it work. you see. And now we can have any kind of implementation. For instance, we can have implementation like this, we can have implementation like this, we can have implementation with no values, we can have no, we should have string always, and because we decided to make it like some string. This can be, doesn't matter what. And yeah, so any kind of approach can be done here. So now if we run this, we'll see all the possible things here. So for our first one, as you can see, we pass all these things. Here we pass, or maybe, yeah, let me actually change it, ABC, and yeah, maybe something like this. So for our first string, we have 2, ABC and true. That makes sense. For the second one, we have 2 and nothing, because we have nil here. In this case, we just pass nothing. And our flag is default, which is false. For our third one, number is 0 by default, string is nil, and flag is false. And for the fourth one, we have default number, we have default flag, but we have a custom string here. Awesome, right? So this is how you can implement your custom methods with default values, which is quite useful. In this case, you just need to use just one method, because otherwise you would need to introduce so many different methods. One looking like this, another looking like this, and another one just like this. And you would have to implement all of them. But now you don't need to do this with this signature and with this extension. Another thing is to use type alias in our protocols, which is quite useful. For instance, imagine you have maybe to-do list app, and you have lists, and you have maybe some methods, and maybe you have some data provider that is that gets your lists, maybe, or returns some, doesn't matter what, and maybe from create list with title that is string, and maybe you have some similar thing like a task data manager, fetch tasks in list. Let it be string for now, because we don't care about this implementation details. Maybe create task, and maybe func mark as completed task. Let it be string. In this case, you just can create just one simple type alias that will be data provider protocol, and probably we want to make all of these protocols, and it will be just list data provider protocol and task data provider protocol. And by doing so, you can move these things into different files, and you'll separate all this logic between two classes. So it's cool, and it makes your code more readable. And yeah, this is actually what happens, for instance, with the Codable. So basically, Codable type alias is basically a type alias. Codable protocol is a type alias for encodable and decodable, if you ever worked with these protocols. So yeah, this is something that's really useful. Just remember that protocols is such a useful tool, and in many cases it works better than inheritance or something else, and you just should go with protocols because, for instance, you cannot subclass structures or enums, while here you can actually do this with your protocols. Yeah, so to make your code better, try to use protocols and try to separate your logic and hide it behind protocols. In this case, your code will be more readable, more testable, and also protocols can help you with documentation, because if you have many methods and you try to add some documentation, it takes so much space. So you can actually add some documentation here, some docs, number, some string, weird flag, and then you just check this method and you see this documentation that has all the things that you added to your documentation. So in addition to that, protocols allows you to add documentation that won't just take too much space in your implementation and won't make your class bigger than it's supposed to be. Yeah, and also I think it's worth mentioning that some protocols may have generic values, so you can create some protocol that will have some associated type, and you can just create methods like fetch type and some stuff of this type. Yeah. And in this case, this type may be different. Yeah, it should be with type maybe, I don't know, element maybe. And if you're creating an extension, for instance, you may want to create some protocol extension where element equitable. And in this case, you'll be able to just simply introduce some other things like is equal and just put one element 1 that is element and element 2 that is element, and just maybe compare them because they're equitable, and that's pretty much it. So, and whenever you use this protocol with some type that is equitable, you'll be able to use this function, otherwise you won't. For instance, you have some class ABC that is not equitable, and you're using some protocol like some class ABC implementation, that is some protocol, and here you have page, and this element will be maybe int or ABC. Here's some code. Yeah, you can actually add this type alias, let ABC implementation. When you create it, you cannot just use like is equal, it doesn't exist. But if your ABC is equitable, or for instance you have some other thing like indentation, sorry for my naming, but it should be fine. In this case you have element that is of type integer, which is equitable. You can have this fetch thing here, and also if you create like some implementation method, you can use is equal because integers are equitable. Yeah, so this is one of other useful things here, and yeah, that's pretty much it. Yeah, I think we can stop here. I've covered a lot in protocols. I should stop here because it's taking long, and yeah, let me know what else you use in protocols, how you can make them even more powerful. Feel free to share that in comments, and let me know what you would like me to talk about, and I see you in the next video.